Hello and welcome to day 2 of Math Club. Today we're going to talk about cross multiplication and literal equations. But first we have a warm up. I'll let you know the first two problems are going to be improper fractions, so make sure you're getting that when you're getting your answers. Pause the video here and come back for the answers. All right, so I got the following for my answers. I got negative 13 over 3, 43 over 7, all real numbers, and no solution. If you got these answers, fast forward uh, to the next slide, or just fast forward until a problem you got wrong. Let's go over them. I'm going to move these down just a bit so that way I have room to solve my problem. The first thing I need to do is simplify each side, which means on the right-hand side, I want to distribute this 2 to everything inside. That gives me a 2x plus 2 minus 8 equals 5x plus 7. Here that gets me 2x minus 6 equals 5x plus 7. Then what I'm going to have to do is subtract 2x from both sides, and that gives me 3x plus 7 equals negative 6. I need to subtract 2x from both sides because essentially there's more x's on the left. We also could subtract 5x from both sides, but that gives us a negative 3, and we're dealing with more negatives there. Now I have 3x plus 7 equals negative 6. So now my goal is to get rid of this addition by 7. So I'm going to do the opposite operation of addition. What's the opposite of addition? Subtraction. So I'm going to subtract 7 from both sides. So that gives me 3x equals negative 13. And now we have 3 times x. So to undo multiplication by 3, we're going to divide by 3 because division and multiplication are the opposite operations. 3 over 3x gives me, 3 over 3 times x gives me 1x, and x equals negative 13 over 3. I like to leave this answer as an improper fraction. If you wanted to write it as a decimal, you'd need to do negative 4.3 repeating. If you didn't put the bar over the 3, we'd count you wrong because 0.3 repeating is very different than just 0.3. Let's move on to the next one. So in our next problem, we have distribution on both sides. So I'm going to do the distribution on the left first. This gives me a 3x minus 12. And on the right-hand side, this is going to give me a 24 minus 4x, and then plus 7. Again, I'm going to simplify my side before trying to move any variables over. So I need to combine the 24 and the 7 because they're like terms. I'm not going to combine my 4x with it, or negative 4x, because it has an x. So it's not a like term. Now we need to figure out where we want to move our x's. I say that 3 is bigger than negative 4. So I'm going to add 4x to both sides to get rid of that subtraction by 4. And this gives me a 7x minus 12 equals 31. Then I have to say, all right, I need to isolate the 7x first, which means I need to get rid of this minus 12. So we're going to add 12 to both sides. This gives me 7x equals 43. And then our last step would be divide by 7, and that gives me x equals 43 over 7. You do not want to try to write that as a decimal because it takes a while before it repeats. And do not give me a decimal approximation either. That would not be correct. We're not rounding here. So on this third problem, we've seen before where we might try to multiply over by that 4. However, both 4x and 8 are both divisible by 4. So I think I'm just going to distribute it. This gives me a 3x plus 6. On the right-hand side, I can combine the 5x and the negative 2x to get a 3x, and then also have that plus 6. And then look, we have 3x equaling 3x, and plus 6 equaling plus 6. Essentially, if we wanted to set this or subtract 3x from both sides, we would get 6 equals 6, which means that any value for x, any value that we put in, would work. And so our answer is all real numbers. However, on the fourth one, we have a little bit different problem. I don't know where a circle came from. That's weird. On this fourth one, we're going to just distribute the negative. So this gives me 5, and then negative 1 times 4 would be negative 4. Negative 1 times negative 2 would give me a positive 2x equals 2x plus 10. This in turn gives me 2x plus 1 equals 2x plus 10. So they both have the same coefficient for their variable. So if we subtracted 2x from both sides, though, we'd get 10 equals 1. Is there any way that 10 can equal 1? No. And that's why it's no solution. So let's talk about solving when a variable is divided. We could also rewrite this as like 1/3 times x plus 2. And you may say, hey, Mr. Herb, I feel super confident with fractions. I'm just going to distribute the 1/3. And you can definitely do that. However, we may also want to just multiply by 3 on both sides. So that way the 3 over 3 reduce. Essentially, this is what happens. I would get 3 over 3 times x plus 2. And 3 over 3 is just 1. So I'm left with x plus 2. Now, from here, what we can say is that we also need to distribute the 3 to everything on the right-hand side. This gives us 6x plus 12. At that point, we're just really able to solve for x like we normally would. We're going to subtract x from both sides to get 2 equals 5x plus 12. And then subtract 12 from both sides because subtraction is the opposite of adding. And we get negative 10 equals 5x. Thus, x equals negative 2. We divide both sides by 5. If you'd like, you can plug negative 2 back in, and let's see what we get. Negative 2 plus 2 over 3 equals 2 times negative 2 plus 4. 0 over 3 is equal to negative 4 plus 4? Yup, I agree. X equals negative 2. Ooh, let's try one a little bit more complicated here. So for one like this, we have a divisor on both sides. So we can multiply both sides by 4 because that'll get rid of this division by 4. Let's start off with that. We're going to multiply both sides by 4. And this gives me x plus 3 equals 4 times 2x minus 1 over 3. But we still have that problem of dividing by 3. We don't really like dividing by 3 because 2x and negative 1, none of those numbers are divisible by 3. And 4 isn't divisible by 3. So we now need to divide, or we need to multiply both sides by 3. That will get rid of our division by 3. So this gives us 3 times x plus 3 equals 4 times 2x minus 1. And now we get our answer, right? Now we're able to solve for x. So we can just distribute our 3 to everything inside to get 3x plus 9. And distribute our 4 to get 8x minus 4. Now let's solve this one more time. We're going to say, okay, we have more x's on the right-hand side. So we're going to subtract 3x from both sides. And this gets us 9 equals 5x minus 4. And then we're going to add 4 to both sides and get 13 equals 5x. And then divide both sides by 5 and get x equals 13 over 5. I apologize for kind of writing all over the place, but this gets us x equals 13 over 5. We could plug that in, but we might need a calculator to kind of help us out to see if that works. Now notice we took a whole bunch of steps just to get to 3 times x plus 4 equals 4 times 2x minus 1. There's got to be a better way. And that way is something called cross multiplication. Your parents would love to help you with cross multiplication because this is the way they definitely did math back in the day. Cross multiplication. What we can essentially do is we can say, well, hey, these both have denominators. And so I'm really going to multiply the 4 by the 2x minus 1 and the 3 times the x plus 3. So we can just do that all in one foul swoop. This gives me 3 times x plus 3 equals 4 times 2x minus 1. We're essentially taking the denominator of the left-hand side and multiplying it by the numerator of the right-hand side. We put that on the right-hand side, and then the denominator of the right-hand side times the numerator of the left-hand side. This will then get us 3x plus 9 equals 8x minus 4, and hey, that's the exact same thing we were doing before. Try cross multiplication out on these next couple of problems. Go for it, you try. I have 3 problems here. Oh no, you can't see that last one. Let me try to adjust my screen real quick. It looks a bit clunky here, but now you're able to see these 3 problems. Pause the video and try these out. Again, for those second and third one, try out cross multiplication. You're going to find it so much easier. All right, I'm assuming you've tried out all 3 problems. You got the answer is v equals 1 for the first one, g is 22 over 5, and x is 45 over 4. The last 2, we can't really guess those numbers, right? Whereas we might be able to plug in 1 and be like, oh, that makes sense. So let's try to solve these. For our first one, again, I'm going to move these so that way I have a little bit more space. Let's try to solve this one. Here we only have one divisor, so I'm going to multiply both sides by 2. The 2 over 2 reduces down to 1, so we have 1 times 3, or sorry, 1 times v plus 3. We're not really going to write that. And then we have 4 times 2, and then that 2 times negative 2, so that gets us a minus 4v. We're going to add 4v to both sides because 1 is greater than negative 4. And this is going to get us 5v plus 3 equals 8. Subtract 3 from both sides to get 5v equals 5. And then divide by 5 to get v is equal to 1. Again, we subtracted 3 because that's the opposite operation of adding by 3. And we divided by 5 to get 1v. So we had to divide by 5 because that's the opposite operation. All right, let's try out this next problem. Oh, that was the third problem. Let's try out this next problem right here. There we go. This is a prime candidate for cross multiplication. Notice how they both have a divisor. So we're going to do 4 times the quantity g plus 4. And then negative 3 times the quantity 2 minus 3g. So 4 times g is 4g. 4 times 4 is 16. Negative 3 times 2 is negative 6. And negative 3 times a negative 3g gives us a plus 9g. Remember that a negative times a negative makes a positive. From here, we again kind of have that conundrum of let's get our variables all to one side and our constants everywhere else. A constant's just a number without a variable attached to it. So we say, okay, well, I think there's more g's on the right-hand side. I'm going to subtract g from both sides, or 4g from both sides. 4g minus 4g is 0g. And this gives us 16 on the left-hand side. We still have this minus 6 on the right-hand side, and now just a plus g. Now I need to get rid of a minus 6 or a subtraction by 6, kind of the same thing. So I add 6 because negative 6 plus 6, those will cancel out. We have to do it to both sides to keep our equation equal, and we get 52 equals 5g. From there, we're able to just divide by 5 because, again, we want 1g, not 5g's, so the opposite operation of multiplication is division. And we get g equals 22 over 5. Let's do the final one. Some of us might have been really concerned on this one because we had variables right on the same side. Oh no. Really what we're trying to do here is we're still going to do cross multiplication. On the right-hand side, I'd have 5 times 2x minus 3. And on the left-hand side, I would do 6 times x plus 5. We really want to make sure we're keeping the numerators on their corresponding sides. Even though it's equal, if this problem were something like an inequality, then we'd have to really watch where we were going because the sign could change everything. We distribute our 6 to get 6 times x is 6x, 6 times 5 is 30, 5 times 2x is 10x, and 5 times negative 3 is negative 15. I'm then going to subtract 6x from both sides. because there's more x's on the right-hand side. 10's bigger than 6. That gives me 4x minus 15 is equal to 30. And then we add 15 to both sides. This gives me 45 equals 4x. Dividing by 4 on both sides gives us x is 45 over 4. And again, we're not really going to try to write that as a decimal or anything like that. We could, but try to keep it as an improper fraction. All right, let's get to the second part of our lesson, which is literal equations. A literal equation is an equation with more than one variable. Most equations you see are literal equations. All rules apply when solving for a variable. One of the more famous ones that you're going to be dealing with is slope-intercept form, y equals mx plus b. A lot of times here we might solve for the b value, or we might solve for slope, right? We might solve for x if we want to, get it in a different form. But that's a literal equation. So every operation here, we're going to be solving for y. Everything that we're doing, we're going to treat kind of everything else almost as if it's a constant, right? Now, we might not be able to combine, but that's okay. For example, on this first one, the first thing we're going to have to do is getting rid of this 3x. We don't want the x and y together. We want just one y. So we're just going to subtract 3x from both sides. Now, we can't combine the 4 and the negative 3x because they're not like terms. One has an x and one doesn't, right? One has an x to the first and one's just a constant. We want to write our variables first. And now we're just trying to solve for one y. So we say, okay, well, this is put together 2 times y. Let's do division because that's the opposite operation. So y equals negative 3 over 2x plus 2. And that's our final answer. Y equals negative 3 halves x plus 2. For the second one, now we have a multiplying by a variable. That's okay. We still want to kind of get rid of the 7 first. So because it's adding 7, we're going to subtract 7 from both sides. That gets us xy is equal to 3. And then from here, we say, well, how are x and y put together? Multiplication. So we're going to do division to get rid of the x, right? We essentially want to get x over x, which reduces down to 1x. And now we're with y equals 3 over x. Final answer, right? Looks kind of confusing, but not as bad. On this third one, you may be tempted to distribute the y, but then you realize, wait a minute, I'm solving for y. Why would I want to distribute it? Instead, just divide by everything it's multiplied by. We're going to divide both sides by a plus b. So y is equal to 6 over a plus b. And there you go. That was a one-stepper. Definitely doesn't look like a one-stepper, but it is. Hey, here's 3 problems. Let's see if I can move this one up real quick. Oh, or just draw a purple line. Try to solve these 3 for their respective variable. Pause the equation here, or pause the video here and try to solve these 3 equations. All right, so for this first one, we're just solving for r. We just need to get r by itself, and it's currently being multiplied by t. So we're going to divide both sides by t. So that way we can get the t over t to reduce down to 1. This gives me rate is equal to distance over time, or r equals d over t. This is a famous equation that we're going to use a lot as well. Let's pop down to this second one. This is a conversion between Fahrenheit and Celsius. So what we're going to do here is we need to solve for Celsius, or the C. This little star here means multiplication. So we're going to subtract 32 from both sides and get F minus 32 equals 9 over 5 times C. Now, we want to get 1C. We could multiply by 5 and then after that divide by 9, but I think it's a lot easier to just multiply by the reciprocal of 5/9. And if you're still not comfortable with multiplying by reciprocals, that's okay. We're gonna spend some time doing that. So this gives us 5 over 9 times F minus 32 equals C, which means that essentially Celsius is equal to 5/9 Fahrenheit minus 32. And if you know anything about temperatures, right, Fahrenheit freezing is 32 degrees, whereas that Celsius is 0 degrees. So that kind of makes sense for us. And for our final one, we're dealing with an equation in standard form. So standard form has a and x on the same, or x and y on the same side. We're going to get solving just for x. So we're going to subtract 6y from both sides because it's put together with 3x by addition. So subtracting will get rid of it. This gives us 3x equals negative 6y plus 10. And then we say 3 and x are put together through multiplication. So let's divide. This gives us x is equal to negative 2y plus 10 over 3. And again, leave it as an improper fraction. You may say, well, Mr. Erb, what if I wrote it as negative 6y plus 10 over 3? Those are also technically equivalent, right? I like to simplify where we can, but I couldn't count you wrong for that. All right, if we get to it in the lesson, we're going to talk about these perimeter problems and this angle problem. However, I recorded this in the last video, so I'm going to stop the video here. And if you need to go over these ones, go back to day 2 and watch that video. If you have any questions about this lesson, please feel free to reach out, send me an email, or ask a question in the comments. I am here to help. Have a great day, and I'll see you next week.